What's up, nerds? Harbinger here. Flip video. It's been a little while. We're going to cover something pretty interesting today called interfaces. It's definitely new. It's definitely weird. Sorry, there's no meme for the day. I don't have time for memes, and I know the people in room 38 have no idea what it means to lack the time for memes, but hey, I am the meme today. So I'm both dank and good. Let's talk about interfaces really fast. So, interfaces are they're the way to like tie classes together. They are not GUIs. They are not graphical user interfaces or anything like that. They're just a way to have like classes have some commonalities. We talked about this one in class. I'm just giving you a heads up. So you look for something they could potentially have in common, and we usually focus on methods, right? Because interfaces are just like collections of method signatures. So what I'm going to do is I'm going to start my first interface here. I'm going to say public interface, and I think a lot of people are going to goof this up because when they try to add an interface to a Java project in Eclipse, they are going to accidentally pick class. It's important to pick interface instead. And I'm going to call mine noisy, and that's going to seem really familiar shortly, but public void make noise. And this isn't a big surprise because you've been doing this for a while, right? Like we've had cat class make noise, and puppies make noise, and instruments make noise, and pirates make noise, and all sorts of things make noise. They are all noisy objects. So public class, something that's noisy. So let's say pirate, I guess, right? And pirates make noise very differently than other classes. So regular class stuff, meaning variables and constructors and accessors and mutators, that's awesome. We would have methods too. Methods like public void, like steal gold or something like that from another pirate. You know, other, and that does stuff. Maybe, you know, this dot gold increases by the like 100 or something, and the other one loses 100 gold, whatever. But what I really want is I want the pirate to have a make noise method. So what I do is I implement noisy, and immediately you're going to see in Eclipse there'd be like an underline thing, and it says something like unimplemented methods or something like that. Do you want to include them? I think it's a better idea to not do that. I think it's good practice to make sure you type it in yourself, because that means you understand what an interface is. An interface is like a promise to include that method. So I promise I'm going to have a public void make noise for a pirate, and I'm living up to my promise here. And all I'm going to do is like SOP, you know, arg or something. Whatever. Hey, I delivered on my promise, I'm good. And then I'm going to have the same thing all over again. I'm going to have something like public class parrot or something, whatever. And I'm going to have the regular class stuff. So variables, constructors, accessors, mutators. Again, it's there and we've been doing it for a while, so I'm not really going to sweat it. But implements noisy, and that means parrots are noisy objects. Not a big shocker if you've ever been around a parrot. They're noisy. So public void, I have to have a make noise method. And you better believe parrots are gonna, like, you know, squawk. Works for me. You know, Polly wants a cracker or something. I delivered on my promise. The parrot made a noise. So I'm happy so far, right? Like, if I wanted, if there were other interfaces out there, I could easily put like a comma, you know, smelly or something like that. Actually, I guess I could put that for pirate too. But I don't have another interface made, so this is good enough for now. Understand, please, there are no variables in the interface, right? There's no constructors. There's nothing other than method signatures. Note the lack of variables, constructors, method bodies. So, you know, there's no method bodies because it's up to each class to decide how it makes noise. There's no constructors because you don't have a noisy object. No one says, oh, that's a noisy thing. You can be a kind of a noisy thing, like a pirate is a noisy thing. You know, a pirate is a kind of a noisy thing. Same thing with a parrot. Variables, there's some technicalities there that we're not going to talk about, but whatever. So we talked before about, in class, the point of this was you can make an array, right? Like noisy array called like loud or something like that. And I'm going to fill it with noisy objects. Heck, I'm going to be really dorky and say like new pirate, and I'll use like the default constructor. I'm going to put in another new pirate, and it's named like, I don't know, Greenbeard or something like that, with 1,000 gold and a hook for a hand or something, and I don't know, something else going on there. I'm going to give him a parrot on the shoulder, because I think the pirate constructor had a parrot also. Now, I'm also going to have a new parrot separately. And new parrot, and I'll use the parameterized constructor here. Poly, and Poly's male. Dying to make a Nirvana reference about Poly, but, you know, Poly wants a cracker. It's about as far as I'll go. So I've got a noisy array. It's full of loud things. It's got a pirate in there. It's got another pirate in there. It's got a parrot in there and another parrot in there. Wait, Harbinger, isn't this one parrot a thing too? Yeah, but it's not in the array. A pirate has a parrot in this case, and a pirate is loud. So there's a has a relationship and there's an is a relationship. A pirate is a loud thing. A pirate has a parrot. Technically, I can make this thing make noise too. You know, loud one dot get parrot dot make noise would work. I'm just not doing it here. So anyway, I'm a big fan of this. For every noisy, let's call the dummy variable n or something like that. I don't know, like noisy thing to be really explicit. And it's in the data structure loud. Let's make it make noise. So noisy thing dot make noise. So that one works, right? So the pirate is going to say arg, and this one's going to say arg, and this parrot's going to squawk, and this parrot's going to squawk. That's good. That's what we want. Is it possible to ask this guy to do something else? Like, can he steal gold from that one or something like that? So could I say something like loud 0 dot, you know what, let's just SOP. SOP loud.0.get, you know what, I'm not even going to do 1, that way you can see it. Get name. Now, this is a concern because, first off, it doesn't work, right? You'd think, like, wait, but loud1 is this pirate right here, and it has a name, Greenbeard, and oh my gosh, how come this doesn't work? Well, for one thing, when you ask loud, the array, to go get you something, like a pirate in this case, the only things it can do are the things that the loud interface grants it access to. Which means you go up to the loud interface and you're like, oh, sorry, the noisy interface, they can make noise. There is no get name in here, which is funny because pirates and parrots both have a get name. If I really wanted, I could say public string get name goes right in here, but I didn't. This doesn't work. Heck, just to show you the real difference, get gold, it's not going to say 1,000. Wait, but this pirate is in position 1, and the pirate has gold, it has 1,000 gold, how come it doesn't spit out 1,000 gold? That's because, as far as Java knows, the thing that's coming out of that array is a noisy object. It could be any noisy object, not one that necessarily has gold. It could be a parrot. It could be something else that's noisy. We don't know. But I know it's a pirate. Well, the cool kids remember how to cast. If you are absolutely certain that thing is a pirate, and I'm probably going to overkill the parentheses, but that's just me, you can cast it as a pirate. What's that? You know loud1 is a pirate, so I'm going to force you to be considered part of the pirate class. You are now a pirate object, even though it kind of was in the first place. hey, this pirate object, go get me your gold. So that works. That actually would spit out 1,000. That's cool. The question is that. Can you force a parrot to be a pirate? Right? Like, hey, parrot, can I cast you like a pirate? You know, we can cast doubles as ints, and we can, like, ints and doubles. There's some weird stuff going on before, like, with other variable types. Can you mix and match classes? Hey, if a noisy thing can be forced to be a pirate if it was a pirate in the beginning, can a parrot that's a noisy thing be cast as a pirate if it wasn't a pirate in the beginning? And the answer is no. This is called a class cast exception error. Class cast exception. I don't know if that's on the subset that you're going to be tested on or not, but I've made this error so many times that it's like an old friend. I'd rather you not make the error, but I feel like this is legal for the AP test. You should know that you can force something that was originally a pirate that's stashed in an interface array. That's okay, but you can't force something that wasn't originally a pirate to act like a pirate. So you know what? I am going to show that difference. Perfectly fine. So just be really super careful, please. Whew. All right. And hey, is there a way to check if an object is of a certain class or not? The answer is yes. It's called an instance of. It's a special word. It's purple. It's all lowercase. It's all one word, but you don't have to know it for the AP test. And we're not going to really go over it in class, but trust me, instance of is a lifesaver sometimes if you've ever wanted it. It's like this, but we're not doing it, so I'm not going to sweat it. Okay, the last thing you should know about interfaces. There's a famous one. There's actually two famous ones, but I'm going to focus on one. So second place, silver medal for famous interfaces is list. A lot of classes implement list, like linked list implements list, array list implements list, and they have things like get. I bet they have size or add, basic stuff too. But for now, we're not going to talk about the list interface. It's cool. You should probably know about it. But the most important one of all is comparable. So, whoa, I spelled it correctly the first time. Comparable interface allows objects to be compared to one another. Wow, no typing errors yet. I should drink more coffee more often. That being said, I'm going to have like 10 errors. But so the comparable interface, you've actually seen this before. We talked about it in class. Someone said strings have a compare to, right? Because the comparable interface has one method. See, typing errors. There we go. It has public int compare to object other. So public always. Int, yes. Those of you that remember comparing strings with compare to other strings, remember that it can give back a number. And we talked earlier in the year, hey, what does that mean when it has a number associated with it? And people said, oh, that's how many spaces away in the alphabet it is. You know, like, let me think. Cat compared to dog is -1 because alphabetically C is one space before D. You know, cat compared to Care Bear, all lowercase, is 2 because the C's match, the A's match, but cat's T is 2 spaces after the R in Care Bear. So it lexicographically compares them. Smartest thing I'm going to say all day. And it's always object, right? Like you couldn't specify a class in there because that means anything that implements comparable would have to know what that class is. But everything is an object. So something like, what if you wanted to compare, I don't know, students or something like that? You know, something awful. Something a good teacher would never do. That being said, I'm going to do it. Public class student implements comparable. So far, so good. How do you know what? I'll be a decent teacher for once. I'm not going to compare students, you know, based on certain criteria like GPA or amount of hours studying or how nice of a person they are. Instead, what do we want to compare today? Let's compare pirates while we're at it. So before they implemented noisy, and I'll keep that just to show you that you can implement more than one interface, and I'm going to go up and steal the pirate stuff. You know, who in the world would steal from a pirate? Yikes. But so far so good, but I promised to provide the method for compare to. Public int compare to, and it's a killer because a lot of people are going to do this. Oh, hold on, Harbinger. It's other. You didn't live up to your end of the deal. The end of the deal was it has to be public int compare to object. This is the only one that doesn't matter. Object other. I think if you auto do it in Eclipse, it's object obj or something like that. But it's a parameter name, and you can name a parameter whatever you feel like. This is going to be a fake answer on the AP test. Public int compare to pirate other. They might have void in here. Whatever. It's got to be public. It's got to be int. It's got to be compare to. It's got to be object. Because that's how compare to works, right? It can work for anything coming in. So the question is, how do you compare to pirates? I'm going to compare them by gold, right? Like the better pirate has more gold. What I can't do is say this dot get gold is greater than other dot get gold for the exact same reason. Hold on. Return. I don't know. Return what? Return the difference in gold? Return 1 for like, yeah, I have more than you. And if it's equal, it's a 0. And if it's, otherwise, it's -1. This is programmer's choice. This is you making a smart choice, what makes sense for the class. So you got to be super careful how you do this one. For me, I'm going to do the difference between, whatever, that. I kind of wanted the difference between them in terms of gold, but I'll do it like this. Again, doesn't work. Please don't think I'm like ending it right there. It's not done yet. So what if they're equal? I'm going to return a 0. Else return -1. Whew! So this doesn't work because this says object. That's like saying if I compare a pirate to a cat. Well, does a pirate have more gold than the cat? What? The cat doesn't necessarily have gold. And if I compare a pirate to another pirate, right now it's considered an object coming in. It could be anything. Java doesn't know. So just like up above, we have to cast it. I'm forcing this thing to be a pirate. If it's not a pirate when it comes in, if I try to compare a pirate to a cat using the pirates compare to, it's going to be a class cast exception. But I can compare a pirate to another pirate and be okay like this. So same deal here. You better be better at typing than me. You better be comfortable casting classes like that. This is a perfect compare to method for pirates. Now the question is, what if I don't want there just to be a plain old tie? What if I want there to be a tiebreaker? What if I'm looking at two pirates, they have the same amount of gold, but I think one pirate is better than another pirate? What if, if one has a parrot and the other one doesn't? Maybe he's a better pirate or she's a better pirate. You could, of course, have other else ifs in here. Like you could have nested ifs. Hey, if they're tied, then let's compare them according to parrot status. That works. I'm just not going to do that. Right? For now, this works and I'm happy. Compare to is important because I get to sort them later. If I have an array of pirates or an array list of pirates, I can actually sort them using compare to based on their gold. So that's actually not that bad. So I think that's it for interfaces. Just to remind you, interfaces are declared like this. Just the method signatures with a semicolon, no variables, no constructors, no method bodies. You can never have a pure noisy, like this is wrong. Noisy, noise equals new noisy. This doesn't work. Noisy lacks a constructor. It's not a class that you can make objects from. Wrong. Anyway, when you implement the interface, you promise to do that method. You promise to fully implement it. You promise to fully give a method body to it because you are living up to your promise. Parrots do it. Pirates do it. You can have an array of those things. That's really helpful. You can have an enhanced for loop. You can have a regular for loop. I'm happy no matter what. You can cast, right? You can cast wrongly. And comparable is the most famous one of all. It has a single solitary method called compare to, in which you can compare this thing to an object coming in. How you handle that object is really important. So, the lab's nice. I hope you enjoy the cartoon I included. I hope you enjoyed the notes I uploaded. The notes are kind of old, so bear with me if, I don't know, they're slightly different. But other than that, enjoy the lab. Harbinger out!